voice is coming? Screen? Okay, fine. And its text is clear?
Yes.
So fine. Okay. So till now we have discussed various points on the operating system. For example, we have discussed what is operating system, what are the types of operating system, what are the characteristics, goals, and other important parameters. So now we'll systematically go through the points very quickly, and we'll see how actually our operating system works. So first thing, what is the operating system? It is nothing but the interface between the user and application. So it is nothing but the interface between the user, that means application program, and the hardware, and it provides various services. Its main responsibility is to manage resources present in the computer system. So how various components are connected? First, our hardware devices are there. On top of that, our operating system is there. Then our applications are there, and finally our user. So the responsibility of the operating system is to provide services to the user using the application programs. So there may be various users, various application programs, those who are using the hardware or using the software. So this is the generic block diagram of the operating system. Initially, computer hardware is there. On top of that, our operating system is there. On top of that, various processes and applications where users can interact and they can access the services. So what are the goals of the operating system? There are two types of goals. We can categorize the goals of the operating system into two categories. One is the primary goal and the next one is the secondary goal. User convenience, user friendliness, easy interacting, these are the primary goals for the operating system. And what are the secondary and major goals of the operating system? These are nothing but the efficiency, throughput, effectiveness, reliability. Okay, we have already discussed these points. Next, how operating system starts or how our computer starts. We have understood this concept with Iron Man concept. So initially, first when we power on this system, our BIOS will initialize. It will first check all the components are connected properly. After that, it will find the master bootloader. Then master bootloader will come into the picture. You can say that is all. You can say that is all. The master bootloader will come, and the main responsibility of the master bootloader is to find whether all the hardware devices are connected or not. Along with that, it has to find the memory. All the memory units are connected properly or not, and they are working correctly or not. After that, the master bootloader will call the bootloader. It will identify the operating system that has to be loaded. And finally, our kernel will come. It will load the operating system in the safe mode, and in the backend, it starts all the services and start providing the interface for the user. So this is the overall flow diagram for starting the operating system, and steps are clearly written. You can quickly go through the steps for your reference. Next, we didn't discuss this point, interrupt. So basically, our computer is the combination of both hardware and software. So when these units need specific or special attention from the operating system, it sends some type of special signal to the operating system, and this signal is called the interrupt. This may come from the hardware as well as from software also. So interrupts are the special type of signal coming from various memory devices, units, or maybe from software. And these interrupts can be categorized into two parts. First one is the software based interrupt, and the second one is the hardware based interrupt. For example, some of the memory units are not working properly, then hardware interrupt comes. For example, memory is overflow. If memory overflow happens, then this is a type of hardware interrupt. Coming to the software interrupt, when some program needs some memory location, or it needed to access some of the other special unit which is operated by the operating system, in that case our program or application or software sends some special signal, and this type of signal is called the system call. So initially program runs in the user mode. When it requires some type of special signal, it sends the system call to the operating system. Then mode will change from user mode to kernel mode. Then operating system finds if the request can be accepted or not. If the request can be accepted, then it provides the service and mode will change from kernel mode to user mode. So initially program will run in the user mode. After that mode will change it to the kernel mode. After that again the mode will change it to user mode. Okay. So this is nothing but the flow diagram of interrupt handling study. So initially the program is running, and if interrupt happens, interrupt service routine will come into the picture. It will solve the problem and give access to the user. So in this place, mode will change from user mode to kernel mode. Okay. So coming to the system call. Any software that requires the special attention from the operating system sends the software interrupt. Software interrupt in terms of system call. It will send a signal called the system call, which is also known as the software interrupt. So when a software or program requires input output or needs some special type of memory or any other special access from the operating system, it sends the system call. Okay. So when our program asks some special resources, the mode will change from user mode to kernel mode. So in the kernel mode, various special resources are there. For example, input-output devices, file management, resource management, various types of resource management units are there. And who is managing all those resources? Kernel. To access the resources or application or software, has to send the system call to the kernel to provide the resources. This much is clear? Okay. And during this step, two main points. During this conversion, mode will change from user mode to kernel mode. So in this kernel mode, application program will be in ideal stage. Okay. When mode will change again with the services, it will again change from kernel mode to user mode. Okay. Now the main point. What are the functions of the operating system? We have already discussed. Process management, memory management, file management, input-output management, security and protection. This is very important. Multiple programs are there. We have to manage the programs or the processes in such a way that they should not disturb each other. This is one of the key components. And finally, the user interface. There are various other functions are there, but these are the basic or common functions of the operating system. Okay. So first one is the process management. When a process comes to the operating system, or for example, you can correlate this one with the your guest also. Just now we have discussed. When some guest comes to your house, you have to manage all those guests. Similarly, in operating system, when program enters into the operating system or enters into the main memory, it has to manage. Our operating system has to manage this process. Similarly, it has to manage all the processes present in the main memory which are being executed. Even those programs it has to manage which are waiting for execution. So management of the process is one of the major function of the operating system. Similarly, memory management. So many processes are there. During execution, they want to store the temporary data in various locations. Even we need to fetch the memory or process from the secondary memory or from the primary memory to CPU. So in that case, memory management is a crucial factor. Okay. And another thing is, when we are managing all these components, all these devices, for example, in our computer, we have input-output devices, we have printer, we have mouse, we have multiple core processors. So while managing all these resource units, all these processes, system will be very complex, and management of this system is very risky. Sometimes we may also face one problem we have already discussed. This one is the deadlock. That means multiple processes are there, multiple resources are there. Somebody is waiting for somebody or some resources which is occupied by other resources. And this is true for all the processes. All are waiting for each other. And maybe there is a cycle, there may not be a cycle, but all are stuck in a circular fashion. So there are various problems are there, various situations are there. For example, some program is waiting for large amount of time, and some program is coming, some important program is coming, and we are unable to provide the CPU. So we have to manage all the priorities, and we have to solve the problem of starvation. That is a large amount of waiting time. Okay. So while managing the resources, specifically input-output resources and devices, we have to take care of these problems. And finally, the file management. For example, creation of file, deletion of file, creating the directory. So these are some of the user-defined inputs. So operating system has to manage users' requirements also. Then security. So multiple programs are there, multiple processes are there. Somebody wants some special memory which is allocated by the operating system to some other process. So in that case, we have to understand that if that process occupies that memory, then it will be a problem. Because if some memory is there which is allocated to me, and some other person comes to me and forcefully he is taking some memory from me, then it is a problem for the operating system and problem for the processes. So security and protection for each of the processes and protection for operating system itself is a crucial factor. Okay, and the user interfaces. So there are various types of user interfaces. For example, command line interface and graphical user interface. So some of the example of command line interface is CMD, shell, that we usually see in our computers. And coming to the graphical user interface, we generally see in our mobile phone, laptop, desktop, tablet. So these are some of the examples of graphical user interface. Okay, so coming to the types of operating system, we briefly discussed about these points. Okay, some of the types are batch operating system, multi-programming, time sharing, multi-processing, distributed OS, network OS, real-time operating system, and embedded operating system. We'll quickly look into the process. So what is batch operating system? Multiple jobs are there. That means multiple programs, multiple processes are there. They want to execute. They want the CPU. So what we have done, we categorize or group the programs, processes, and then allocated the CPU. In this case, execution of the programs or processes will be done one by one. It will enter into the CPU. It will process. It will take the other input-output unit. Again, it will come back. It will complete its execution. Then only it will leave the CPU. That means during the execution, one program completely occupies the CPU, even though sometimes our CPU is idle. Okay, but it is very easy to understand, easy to implement, and management is very complex because we have to categorize the job, and the CPU is idle for large amount of time. So these are some of the limitations of batch operating system. Okay, so coming to the multi-programming operating system. So what we have done, we told the operating system, don't wait for other programs or processes. Instead, you make ready some of the processes, bring them and store in the main memory. If some process go for collecting I/O or CPU is idle for such amount of time, you fetch some job from the main memory and allocate to CPU. In this way, utilization of CPU will increase. But the problem is execution will be done one by one. Still, compared to batch operating system or multi-programming operating system, provides higher throughput while utilizing the resources. Okay. Coming to time sharing. So, in previous technique, there is one major problem is there. Starvation is a major problem. Some of the programs are waiting for large amount of time, and the problem of turnaround time and waiting time. Some of the programs waiting time is very high. To solve this problem, what we have done, we allocated the time instance for each of the processes. So one process will give one time quantum to one of the processes. They will come, they will execute for that amount of time, and again they will go, they will wait. Next program will come, they will execute, they will utilize the CPU, and then they will wait for next round. So in that way, everyone will get chance for the CPU after a specific amount of time. So in this way, we can solve the problem of waiting. Still, these systems are not the parallel execution. So parallel execution is offered by multiprocessor operating system. In multiprocessor operating system, what we want? In multiprocessor operating system, one hardware is there. We have multiple programs, multiple processes. They don't want large amount of memory. So what we can do? We have two options. Either we can buy multiple desktop, or we can associate multiple cores or multiple CPU into a single hardware. So the better is if we manage a single hardware and borrow multiple CPU and utilize that particular amount of resource to process the various tasks. In that case, utilization will be, because multiple programs can come, they can execute parallelly in a single system. So utilization of the resources will be very high. CPU will be busy for maximum amount of time, and degree of multi-programming will increase. That means multiple program parallelly can execute. So this is the benefit of multi-processor operating system. And some of the other operating system is distributed operating system. For example, various operating systems are there which are dedicated for specific purposes. Now we want to access some of the resources. For example, we want to use the Facebook. In that case, Facebook server is there. They have their own operating system. Through an interface, we are using the resources. These are called the distributed operating system. And another benefit of distributed operating system is the storage. We can utilize the storage which is available in various locations. This is another important benefit of distributed operating system. Similarly, we have network operating system and embedded operating system, and important is the real-time operating system. So generally we can see this type of operating system in our cars, in robotic system, air traffic controller system, as well as the some type of medical units in IC also we can see this type of real-time operating system. Okay. And these are some of the popular examples of operating system we have already discussed. Windows